Python has multiple data types and data structures that you can use to store and manipulate data efficiently. In this video, we will discuss the Python data type array.array. Hey everyone, welcome back. Today we're diving into a data structure that often gets overlooked in Python, array.array. If you're working with large numeric data sets and care about performance or memory usage, this built-in module might be exactly what you need. Let's get started. Array.array is a class from Python's built-in array module. It provides a space-efficient typed array, meaning every element must be of the same numeric type, like integers or floats. It looks like a list, but it's more like a compact container for low-level numeric data. Why not just use a list? Lists are flexible. They can store any type of object, but that flexibility comes at a cost. They use more memory and are slower for certain operations. Array.array stores raw bytes, like an array from the C language. That means better performance and lower memory usage when you're working with large collections of numbers. Array.array is perfect for large numeric data sets where performance and size matter. Binary file input and output, like reading or writing large image or audio data files. Interfacing with C code or system-level APIs. Or buffer manipulation where low-level control is needed. If you need compact, type-specific storage and don't want the overhead of a NumPy dependency, array.array is a great choice. Here are a few important things to know. You must specify a type code like I for integers or F for floats. All elements must be the same type. It supports many of the same methods as lists like append, pop, slicing, etc. It's mutable and iterable. And you can easily convert it to and from bytes, which is great for file input-output. Let's look at some examples of how to use array.array. In this example, we create an array of integers. Note how we indicate that the values are to be integer using I as the first argument. Arrays support methods that allow you to adjust the array elements. Here we use the append method to add an element to the array. We also use the pop method to remove an element from the array. We can access array elements using an index. Here we assign a new value to the first element by using assignment on the element at index 0. We can use array methods to convert the elements from their original data types to bytes. In this case, we convert the array from integer to an array of bytes using the toBytes method. Then we use the fromBytes method to convert back to integers. As you can see, array is just like a list, but with added performance for number-heavy operations. So that's a quick overview of Python's array.array. It gives you the speed and efficiency of low-level arrays with the simplicity of Python syntax. It's not a replacement for lists, but if you need tight control over memory or performance, it's a great tool to have. If this helped you learn something new, give the video a like, subscribe for more Python content, and let us know in the comments how you'd use array.array in your own projects. Thanks for watching, and as always, happy coding!